Hello, class. This is Mr. Hart, and in this podcast, I want to finish up the minerals chapter of our textbook. And last time we left off talking about how we can identify minerals based on things like its color and streak and luster and hardness and all those different factors we looked into. But this week, we want to look at how a mineral actually forms. How does a mineral become a mineral? And this can happen in quite a few ways. Um, I have five listed here that I want to go over of how a mineral can form. So the first way a mineral can form is what we call crystallization from magma. Okay. The second is called deposits from evaporated solutions. And the third one is deposits in hot underground water veins, compression under extreme pressures, and expansion in open spaces, which we call geodes. Okay, so let's look at each one of these individually. So the first one, formation from magma. This is a very common way that we can see in things like granite. Okay, this block here that you see is a piece of granite, and it comes from when a some magma or some lava underneath the earth or um, something like that is cooled rapidly. Okay, it'll form some rock around the outside, but also form a lot of these crystals. Okay, because it cools so fast, it can form these crystalline patterns. Okay, and so we'll find minerals like quartz and feldspar and things like that inside the rock itself. So when we get to igneous rock and rock formation, we'll talk more about that. But we can see that these minerals can form from these crystal structures inside this rock. Okay, so that's how it forms when it cools from magma. Another way is one that you're probably familiar with is an evaporation from solutions. Okay, so if you've ever, for example, taken salt water, okay, and you've let it either boil or evaporate naturally, okay, you have all these particles kind of in the water itself, but you can't see them at the time because they're diluted through the solution. But as that water evaporates, the particles can get closer and closer together, and they'll start to form into compounds and minerals as the water evaporates because they're closer together. Um, they can start this formation. So if you imagine, for example, salt water, if you've ever seen, once you evaporate all the water away, all you're left with is salt, and salt's a mineral. Okay, if you've ever seen the salt flats in West Utah, then you also know that this happened. There was a lake there at one time, and as the water evaporated away from the lake, all that was left was all the mineral deposits on the bottom. And that's why we get the salt flats. Okay, so minerals can form from solutions as well. The next one is a really cool one, is what we call from water veins. So you've ever seen like cracks in the sidewalk as you're walking down the street? That happened because water came into the cracks and then it expanded as it froze, okay, during the winter time, leaving a crack. Well, this can happen too in a underground system with rock and underground water aquifers and things like that. But when this happens as well, crystals can come with the water and they can start to form. So these white lines you see in this rock are actually quartz minerals. And so as that water goes in, the minerals can compound, and as the water leaves, all you're left with is this, again, this kind of deposit of minerals inside these water veins. So this is a really cool way that these can form, is from this mineral buildup in these underground water aquifers. Also, with that, sometimes we get um, some cool buildup in just regular lakes and things like that. These are called the tufa towers. They form from calcium springs underwater, and they are at the bottom of Mono Lake. But then that water bubbles up, and the calcium deposits on the top. And then when the lake level drops, you can see that these minerals have built up on the shore. So it's pretty cool how these form. You can see almost like that building up of material bubbling up from the underground calcium springs. And so underground water can form a lot of minerals. In fact, that probably is where we get um, some of the more common minerals like salt and calcium and things like that. Okay. The next one is probably the one we're most familiar with. It's from compression. So pressure over time can take a general rock and form it into a mineral. Most well known is diamond, right? If you take coal and you compress it and heat it up over time, it can form into diamonds. Obviously, not as well formed as in this picture, but you're familiar with this idea that when we compress, with coal and other materials, we can get minerals like diamond. Okay. Then the last one is what we call from geodes, okay, or from these expansions in open spaces. So this is a really cool picture. This is a rock on the outside, if you can tell, that has been sliced in half, and on the inside you have all this kind of emerald deposits on the inside. And so these minerals had that space, and this material is allowed to expand in this open crevice inside the rock. And so the minerals can grow and build off material, and then we get these really cool crystal patterns on the inside. Okay, and so this is called a geode, is when there's a rock with an open space on the inside, and the minerals kind of form inside that open space. So that is the 5 ways that we'll talk about in this class about how minerals can form. And that is actually the end of the mineral chapter as well. So hopefully that makes sense. And let me know if you have any questions. Thank you.